It is January 19th, 2006, when NASA's New Horizons spacecraft leaves our blue home planet for the realms of the remote Pluto system. After a 9-year flight, the unmanned spacecraft reached its intended destination, allowing it to give us a detailed look at previously unexplored worlds for the first time. What amazing fine new horizons recorded on Pluto's surface, and what we've been able to find out so far about this unique phenomenon we'll show you in today's video. Excited about groundbreaking discoveries and distinctive spectacles in the universe? The former planet was added to the star charts on February 18th, 1930. Pluto was a permanent member of our planetary system until August 24th, 2006. However, as more and more Pluto-like objects were detected in the Kuiper Belt, the International Astronomical Union decided to reconsider the official planet definition. So, it came to be that Pluto was classified in the newly designated ranks of dwarf planets with an equatorial diameter of 1,475 miles. The celestial body is significantly smaller than Earth's constant companion. In this category, our moon measures 2,159 miles. Since Pluto moves on a very eccentric orbit on its journey around the Sun, the distances between the dwarf planet and our host star also vary considerably. The largest distance between the two celestial bodies is 4.6 billion kilometers, while the smallest distance is about 3 billion miles. As a result of this large spatial distance, Pluto needs about 248 years to completely orbit the Sun. If one were to look up at the sky from Pluto, the Sun would appear merely as a strikingly bright star and not as a large, dazzling silhouette, as is the case on Earth. The enormous distance to the Sun is also responsible for the bitterly cold temperatures on the surface of the celestial body. On average, the thermometer here drops to minus 44 degrees Fahrenheit. To describe a rotation around its own axis, Pluto again needs about 6.4 days. Just like Uranus, the dwarf planet has an unusually inclined axis of rotation. While to this day, researchers puzzle over why Uranus lies practically on its side, the background in the case of Pluto is obvious. The intrinsic rotation of the celestial body is bound to the orbital motion of its moon Charon by tidal forces. Especially exciting is the fact that the two celestial bodies have a double-bound rotation. This means that they always present one and the same side to each other. With a diameter of 1,746 miles, the satellite is half the size of the dwarf planet. Because of these size relations, it's still being discussed whether it would not be more meaningful to speak in the case of Pluto and Charon as a double planet. Considering the material composition, it's probable that Pluto consists of 70% rock and 30% ice. In detail, the celestial body has a massive rocky core that makes up almost a third of its total diameter. The gigantic stony heart is surrounded by 2 layers of water and nitrogen ice. In this transitional region between mantle and core, melting processes may have formed a huge subsurface ocean, possibly existing to this day. Unique phenomena. On July 14, 2015, it finally happened. The New Horizons spacecraft completed its Pluto passage, passing the dwarf planet at a speed of 9 meters per second. Meanwhile, the spacecraft approached within 7,700 m of the dwarf planet. The mission was able to produce global maps of Pluto and Charon, and the high-resolution images presented the celestial bodies to us in unprecedented detail. A reciting of the New Horizons images now suggests that the dwarf planet harbors a unique phenomenon, namely, a previously unknown form of ice volcanism. The existence of this so-called cryovolcanism has been known for some time. In fact, we also find this exciting natural spectacle on our blue home planet. The volcanic formations do not spit out boiling hot lava or magma, but a bone-chillingly cold ice mixture. On Earth, we find such objects in northern Siberia, Canada, and Alaska, for example. We also know about extraterrestrial cryovolcanism. Ice volcanoes have been detected on Saturn's moons Titan and Enceladus, as well as Pluto's companion, Charon. However, the findings obtained by researchers now suggest that Pluto's ice volcanoes clearly dwarf all comparable formations. In the course of their evaluation, the experts focus on the dome-shaped structures on Pluto's surface, which had not been studied in detail before. Based on the shadows cast, the experts were able to identify which valleys and elevations are hidden in the region under investigation. The exciting result, the 4-mile-high Pitcairn and the 3-mile-high Right Mons are most likely the result of cryovolcanism, novel ice volcanism. Prior to the work, it was speculated that the giant mountains might even be ice volcanoes themselves. However, a detailed analysis of the surface structures quickly showed that Pitcairn and Right Mons deviate significantly from the well-known scheme. Accordingly, the formations have strikingly large and unusually shaped openings which do not correspond in their nature to later collapsed craters. In addition, no clear traces of directed rivers could be found, and there was no trace of material that had flowed out. Instead, the area is adorned by lumpy basement elevations hundreds of feet high and up to 12 miles wide. This circumstance also appears unusual for conventional cryovolcanism. Thus, the Pitcairn and Right Mons environments differ not only from Pluto's other landforms, but also from most other known surfaces in the solar system. Moreover, since the region has hardly any impact craters, it's reasonable to conclude that it must be geologically quite young terrain. Accordingly, the landscape transformation took place only long after the actual birth of the dwarf planet. This assumption is also supported by the collected spectral data. Thus, the basic material of the massive structure is composed of frozen water ice which is as hard as stone. Above this, in turn, is a thin mantle of lighter ice forms such as nitrogen ice and frozen methane. Organic deposits have also been detected in this natural coating. Since the thickness and composition of the shells show large deviations, the assumption suggests itself that these were formed by no means in the same breath, but at different times. In this regard, experts now believe that the gigantic mountains and surrounding terrain were created by a previously unknown form of cryovolcanism. In detail, viscous water ice penetrated from several exit points from the underground to the surface. There, this mobile mass accumulated into dome-shaped elevations, with some of these outgrowths merging over time to form the landscape visible today. A profound theory. With this exciting theory, the unusual appearance of the terrain could be fully explained, and the background of the enormous mountains where today the mighty Pitcairn and Right Mons rise. There were once several closely placed exit gaps. From there, new masses of water ice constantly reach the surface, with the newly emerging material pressing the already existing material higher and higher. If the suspected scenario is confirmed in future studies, Pluto would host a hitherto unique form of cryovolcanism. In the same breath, however, confirmation of the thesis would also mean that the interior of the dwarf planet is in fact significantly warmer than scientists' previous predictions had indicated. Because actually, the internal warmth means that the ice masses pressed to the surface are mobile enough to form such landscape formations. Life on Pluto. In view of the scenario just described, an intriguing question arises. How could the warmth in Pluto's interior rise when the dwarf planet is actually characterized by frosty cold? In this regard, researchers discuss two possible backgrounds. One theory is based on the decay of radioactive elements in the interior. The other thesis is based on tidal forces. By the forces of attraction between Pluto and Charon, the inner areas of the dwarf planet are practically needed. As a result, therefore, great heat will be generated. As briefly mentioned at the outset, it's suspected that Pluto did indeed once possess or may still possess a subglacial ocean. In this connection, some experts introduce an exciting assumption into the field. If liquid water accumulation should still exist, then life could also have developed there. The energy necessary for it would be supplied accordingly by the warmth of the radioactivity and or the tidal forces. The contained ammonia would function as a kind of natural antifreeze and lower the melting point of the ice significantly. According to this, at the very least, the existence of unicellular life forms on Pluto would be possible. And in fact, we now know that the limits of life are not as narrow as was long suspected. A few months ago, researchers in Antarctica succeeded in detecting marine life forms at a depth of over half a mile. Until this sensational discovery, the existence of sedentary life forms under such extreme conditions was considered simply impossible. Now, we want your opinion. What do you think about the novel ice volcanism detected on Pluto? As always, drop us your thoughts, suggestions, and feedback on today's video in the comment below. Are you in the mood for more exciting contributions on the topic of outer space? Then take a look at the other videos on our channel, which you can access by clicking on one of the images in the credits. Thanks for your interest. Take care and we'll see you next time.